right, so we got initial investment of $10,000 here. So start off 10,000. Okay, so remember it's 1 plus our interest rate. So 6% written as a decimal should have been 0.06. And since we're compounding monthly, we got to split up that interest rate over the course of the year. So we divide by 12. Then our exponent, 8 times the number of compounds per year, which in this case should be 12. We put it all into a calculator. I think it's what, 16,141? Yeah, we had it from last class. So $16,141.43. That is how much we have after 8 years. All right, so again, remember this was on the chapter 8 test. It'll be on the next test as well. Okay, under exponentials. So let's make sure we're ready for that. All right, today we're talking about absolute value inequalities. Okay, so we'll take some notes here. If you want to take a second, get out your notebooks, whatever it is you do to take notes on. All right, so before we focus on inequalities, take a look at equations, absolute value equations. So remember, absolute value is going to be your distance on a number line. Okay, your distance from 0 on a number line. Okay, so here we have the absolute value by itself. Okay, absolute value of x plus 1 is equal to 6. Okay, so what are the two numbers that x plus 1 could equal? Well, if x plus 1 equals 6, okay, that's going to give us our answer. Okay, but what could x plus 1 also equal? That would give us an answer of positive 6. Negative 6. All right, so x plus 1 could equal 6, or if x plus 1 could equal negative 6. Okay, because remember, absolute values are always going to be positive. So as we solve these two equations, we get x equals 5, and then we get x equals negative 7. All right, so if we wanted to plug them back in to just kind of double check, all right, we get absolute value of 5 plus 1. And then we get the absolute value of negative 7 plus 1. Okay, so this one's obvious. Absolute value of 6 does equal 6. All right, but then remember, absolute value of negative 6, does that equal positive 6? Yeah. Yeah. Okay. So a couple mistakes that I see a lot is, let's say we have something that looks like this. All right. So again, we're going to write two different inequalities. I'm sorry, we're going to write two different absolute value equations. Okay, our first one basically is just x minus 2 equals 4. Okay, so whenever we're taking these numbers out of the absolute value, okay, there tends to be people that want to make this a positive 2 when you take it out of the absolute value. Okay, but that's not how the world works. Okay, what you do is you change your answer, okay, to a negative. Okay, so anytime you have an absolute value, okay, you write two equations off of it. On the second equation, the only thing you're changing is that this becomes negative. Okay, and that's going to be helpful when we start using inequalities. So we get our two answers of 6 and negative 2. All right, so when it comes to absolute value inequalities, I'm going to take that same problem from above. Okay, instead of an equal sign, I'm going to change it to a greater than sign. So whenever we're solving this, step one is going to be to get the absolute value on a side by itself. And in this example, it's already done. And then from there, we're going to write two different inequalities. Okay, similar to what we were doing above. First one's going to be just as it is. Okay. Now your second inequality is going to be a little bit different. So just like we did above, we're going to make the answer negative. But we are also going to flip the sign. Again, one we're writing as is. just removing the absolute value symbol. And the second one, flip the sign and make it negative. And then you're going to solve both inequalities. And we want to put it on a number line. We have x is greater than 5. Open dot going to the right. And we have x is less than -7. Open dot going to the left. And again, we can always check our work as well. Looking at the number line, okay, what would be an easy number to plug in to see if it does not work? Arjun? 0, right? 0 somewhere in here. Okay, notice it's not on the number line anywhere, or it's not on the shaded region. So if we plugged in 0, we get 0 plus 1, absolute value of 0 plus 1 is greater than 6, which is the absolute value of 1. We end up with 1 is greater than 6. Is 1 greater than 6? It is not. So 0 should not be in the shaded region, which it's not. Okay, and vice versa, you could plug in 6 or you could plug in -8 and plug those in and make sure they do work. All right, so this one a little bit different. Step 1, get the absolute value on a side by itself. Okay, so right now it's 2 times absolute value of x minus 1 plus 3. So let's move this 3 over. We get 2 times the absolute value of x minus 1 is less than 8. Divide by 2. Okay, if I divide by 2, do I need to flip the sign? No, right? Only if it's a negative. All right, so now I'm left with absolute value of x minus 1 is less than 4. Okay, so my absolute value on the side by itself. Yes. So now I'm going to write my two inequalities. X minus 1 is less than 4. And my other one, x minus 1 is going to be greater than -4. All right, just add 1 across the board. My first inequality is x is less than 5. My second inequality is x is greater than -3. Using open dots again. Okay, so on a number line, it shows that my solution is going to be any number greater than -3, but then also less than +5. All right, let's take a look at a couple of special scenarios here. So here we got -2 times the absolute value of x minus 3 is greater than or equal to 4. Okay, absolute value is not on the side by itself. Okay, so what do we have to do? Got to divide both sides by -2. Okay, what happens when we divide by a negative? Flip the sign. All right, so that's special scenario number 1 in this problem. Special scenario number 2. Okay, an absolute value is always going to be what? Positive, negative? It's always going to be positive. So we know that this is going to be a positive number. Is a positive number ever going to be less than or equal to a -2? No. Okay, so this is no solution. Let's see if I can learn how to spell. No solution because an absolute value can never be less than a negative number. All right, on the flip side, let's say the inequality is facing the other way. Once again, we have an absolute value over here on the left, which we know is going to be a positive number. Okay, when is that going to be greater than or equal to -5? So when is a positive number going to be greater than a negative number? Never or always? Always. Always, right? Positive number is always going to be greater than a negative, in this case, 5. So if you get something that looks like this, all real numbers are going to be solutions. Because a positive number is always greater than a negative. So always notice when your absolute value is greater than or less than a negative number. Okay, or 0 as well. Okay, anytime you get an absolute value on a side by itself and the other side of the inequality is a negative number, okay, it's always going to be no solution or all real numbers, depending on which way your inequality is facing. All right, let's have you guys try these on your own here for a few minutes. All right, so just kind of going through these. First one, we got the absolute value already on a side by itself. So we write our two inequalities. First one, like I said, keep the same. Second one, flip that sign and make your answer negative. Now we're adding 3 across the board. So we get x is greater than or equal to 7 and x is less than or equal to -3. Okay, open dot or closed dot? Closed. So greater than 6 goes this way, less than -3 goes that way. Okay, second one is the absolute value on a side by itself. It is not. I'm gonna add the 6 over here first. So now we have absolute value of x plus 2 is less than 16. Now we can write our two inequalities. X plus 2 is less than 16 and x plus 2 is greater than negative 16. Subtract 2 across the board. X is less than 14 and x is greater than negative 18. All right, open dot or closed dot. Open, less than 14 goes this way, greater than negative 18 goes that way. So we're left with these values as the answers. Yes, you know. It should, yes, thank you. All right, third one here, 2 times the absolute value of x minus 1 is less than or equal to 4. Got to divide both sides by 2. Do I flip the sign? No, right? And we're dividing by a positive, we don't flip the sign. So now I have the absolute value of x minus 1 is less than or equal to 2. Right, my two inequalities. First one, I leave the same. X minus 1 is less than or equal to 2. Second one, flip the sign and make it negative. So it's x minus 1 is greater than or equal to negative 2. Add 1 across the board. X is less than or equal to 3. X is greater than or equal to negative 1. Okay, so I got my boundary points there. Should be using closed dots. Less than 3 goes to the left, greater than negative 1 goes to the right. Okay, so I have a small set of numbers that'll work for that inequality. All right, last one. Okay, a little tricky here. Got to add 6 first. Okay, so now I have the absolute value of negative 3x plus 1 is greater than 21. So I write my two inequalities. Okay, negative 3x plus 1 is greater than 21. Negative 3x plus 1 is less than negative 21. All right, so now I have negative 3x is greater than 20 and negative 3x is less than negative 22. Okay, now I need to divide by a negative 3. Okay, in doing so, dividing by a negative 3 means I have to do what? Flip the sign. So I get x is now less than negative 20/3, and x is now greater than positive 22/3. I should be using open dots. Less than negative 20/3 goes to the left. Greater than positive 22/3 goes to the right. Okay, so just be aware. You can still flip the sign throughout these problems towards the end there.